All right, I want to go over this equation, and as usual, we'll start by labeling what we have. So we got 12 volts over here, and then our current going up through here in this direction is 4 amps. So we know we got 4 amps coming back here. And then we've got, for R1, we got 9 ohms. R2, we don't know. R3, we have 4 ohms. And R4, we have 9 ohms. And then I like to also just kind of isolate that these points here all are getting 12 volts. And the very first thing that you might notice is branch 1 with R1 has 9 ohms, and R4 also has 9 ohms, so we know these are going to be the same as far as current flowing through them. And then the one with R2 and R3 is a series circuit. So the very first thing that I know we can solve for here is the current running through the branch of R1 and R4. So I do that by using Ohm's law, which is, in this case, if I want to solve for current, current is equal to volts over resistance. So I go in here, and I got 12 divided by 9, and so my current is going to come out to like 1.33 repeating here, right? So, and I also know that's going to be the same thing for the branch with R4 because it's the same voltage and same resistance. So what I'm going to do in here is I'm going to put a little blue arrow indicating my current flows going through these branches. I'm going to put 1.333 repeating. The same thing over here, 1.333 repeating. That's amps, right, for both of these. Okay. So I know as well, looking over at the following branch with R2 and R3, that there's something curious here. I know I got a total of 4 amps going through this unit, and if I add up the amps going through the first branch and the last branch with R1 and R4, I end up with like 2.6666, repeating amps. So I'm going to subtract 2.66 from 4, and look, what do you know? If I subtract that value, I'm going to end up now knowing that the current flowing through this is 1.333, again repeating, right? Amps here. Same thing. And if you add those three together, you'll come up with 4 amps, so that makes sense. Which kind of tells me that the branch 2 has to be the same resistance as R1 and R4 branches if it's got the same amount of current with the same voltage. So I could just say, oh, well, it's got to be 5 ohms, but let's do it mathematically. If I wanted to solve now for this mathematically, I would do this. Basically, I'm trying to solve using Ohm's law for the resistance value in that second branch for R2 and R3. And resistance is equal to volts over current. And in this case, I'm going to have R2 plus R3, right? I got to add those two together, are going to be equal to volts over current. So a little bit of a variation to what we're used to seeing. So R2, I don't know what it is, but I know that R3 is 4. I know that my voltage is 12, and I know that the amps going through this is that 1.333, sort of like this. So the next thing here would be to take 12 volts and divide it by 1.33, as many threes as you can get. You're gonna end up with something very close to 9, like really close to 9. So I'm gonna write 9 because it's like 9.0000225 or something, and we don't need to go out that far for this. So I'm gonna put 9 there, and put 4 here for this, so we know. So I'm gonna subtract 4, and R2 is equal to 5 ohms. And that's how I end up solving for this. And so the solution in this case, is 5 ohms right here. And you can see that I have proven each branch with the resistances. And so if R2 is 5, we would actually add that because it's a series circuit. If we add it, 5 plus 4 would be 9 ohms, and that would make sense. We would have the same current flowing through each of those. So hope that was helpful for this question and kind of guided you along. Thanks.